Hello dear learners, welcome back to Lesson BCE YouTube channel. Today we will see Kirchhoff's laws basic level. Don't forget to subscribe and like our channel.
So here's what we've got on tap today. First, we'll see why Ohm's law sometimes isn't enough. Then we'll get into the two main players, Kirchhoff's current law, or KCL, and his voltage law, KVL. After that, it's your turn with a little practice, and finally, we'll wrap it all up so you've got these tools ready to go.
All right, first up, beyond Ohm's law. You might be thinking, hey, I know Ohm's law, isn't that enough? Well, not always. Let's see why.
Look, Ohm's law is fantastic for simple stuff. You know, one battery or resistor or two, easy peasy. But what happens when things get messy? Like when you've got multiple batteries, or wires looping all over the place. All of a sudden, just using V equals I times R doesn't cut it anymore. It gets complicated fast.
And that's where our hero, Gustav Kirchhoff, comes in. Way back in 1845, he came up with two super powerful but actually really simple rules that let us figure out any circuit, no matter how tangled it looks. Honestly, these laws are the key to leveling up your circuit game.
Okay, let's jump into his first law, Kirchhoff's current law, also known as the junction rule. This one's all about what happens when currents meet up at an intersection.
So, the law is all about junctions. A junction is just any spot where a bunch of wires connect. And the rule is super simple. Whatever amount of current flows into that junction has to be the exact same amount of current that flows out. Nothing more, nothing less. The best way to think about this, imagine water flowing through pipes. If you have a few pipes all feeding water into one intersection, all that water has to go somewhere, right? It can't just vanish. The total amount flowing out through the other pipes has to equal what came in. It's the same idea with electric charge. It's conserved. It can't just be created or destroyed at a junction. And here's how we write it down. That funky E symbol is just a sigma. It's Greek for the sum of. So this just says the sum of all the currents going in equals the sum of all the currents coming out. For example, if you have I1 and I2 flowing in and I3 and I4 flowing out, well, I1 plus I2 has to equal I3 plus I4. Simple as that.
All right, let's try a quick example. Say you have 3 amps and 2 amps of current flowing into a junction. So what's the total coming in? 5 amps, right? Now, if we see 4 amps flowing out through one wire, how much must be flowing out the other wire? Well, since 5 amps went in, 5 amps have to come out. We've already got 4, so that last one, IX, has to be 1 amp. See? It just has to balance.
Okay, so that's current. But what about voltage and energy? For that, we need Kirchhoff's second law, the voltage law. You'll also hear it called the loop rule.
This law is all about closed loops in a circuit, any path that starts and ends at the same spot. And here's the cool part. If you take a trip around any closed loop in a circuit, the sum of all the voltage changes you see along the way will always add up to 0. Always. Here's another analogy for you. Think about hiking a trail that goes in a circle. You climb up some hills, gaining elevation. That's like a voltage gain from a battery. Then you go down some slopes, losing elevation. That's like a voltage drop across a resistor. But when you get back to your car, right where you started, what's your total change in elevation? 0. You're back where you began. That's exactly how energy works in a circuit loop. It's conserved.
The equation for this is pretty straightforward. The sum of all the voltages in the loop is 0. All this really means is that whatever voltage the battery supplies, the voltage rises, is completely used up by the components in the loop. The voltage drops. It all balances out perfectly. Let's look at an example. We've got a 12-volt battery with 2 resistors, a 4 ohm and a 2 ohm. First, what's the total resistance? 4 plus 2 is 6 ohms. Okay, now we can use Ohm's law to find the current. 12 volts divided by 6 ohms gives us 2 amps. So 2 amps are flowing everywhere. Now let's find the voltage drops. For the first resistor, it's 2 amps times 4 ohms, which is 8 volts. For the second, it's 2 amps times 2 ohms, that's 4 volts. Now for the magic. We get a gain of 12 volts from the battery, we lose 8 volts on the first resistor, and we lose 4 volts on the second. So plus 12 minus 8 minus 4 equals 0. It works. Okay, you've seen how it works. Now it's your turn to try. Let's do a quick practice problem to test your knowledge.
So, check this out. We've got 8 amps of current flowing into this junction. It splits up and goes out through 3 different wires. We know that one wire has 3 amps leaving, and another has 1 amp leaving. The question is, what's the current in that third wire?
Go ahead and pause the video and see if you can figure it out. Just think about that current law.
Ready for the answer?
Okay, so the rule is what goes in must come out. We have 8 amps coming in, we have 3 amps plus 1 amp, so that's 4 amps that we know are leaving. To make it all balance, that third current has to be 4 amps, because 3 plus 1 plus 4 equals the 8 that came in. Hopefully you got it.
Awesome job. So let's do a quick recap and put these 2 amazing rules into your official circuit toolkit.
So here it is, all in one place. You've got the current law, KCL, which is all about junctions and is based on the conservation of charge. And you have the voltage law, KVL, which is for loops and is all about the conservation of energy. These 2 laws, together, give you everything you need to solve pretty much any circuit you'll come across.
So now that you have these tools, think about it. From the circuits inside your phone to the power grid that lights up your city, you now have the fundamental ideas needed to start figuring out how all that stuff actually works. Pretty cool, huh?
All right, that's it for our look at Kirchhoff's laws. Keep learning physics, you're doing great. And don't forget to subscribe to Lesson BC.